Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working over here on the Stoker engine, and previously we got the Babbitt poured for one of the crosshead slides, and after doing that, or actually while I was in the process of doing that, a thought crossed my mind. I didn't say anything about it, and evidently it crossed a lot of your minds too, because I got a lot of comments about it, and I think I'm possibly may have gotten the cart before the horse a little bit by pouring it at this stage. And I'm going to get you in here and zoom in and kind of show you why here in just a minute. But from an alignment standpoint, there was one other thing that I really wasn't taking into consideration that I need to check out before we proceed with the other one. Worst case scenario, we may have to melt that Babbitt out and re-pour this side, but I would rather go ahead and get it checked out before I go ahead and do the other one and have to do both of them. So we're going to take some time here and have to get this a little bit further assembled to kind of verify whether or not we got an issue or not. And probably on the second one, we're going to do a little bit further setup before we do the pour to make sure we don't have an issue, even if this one works out over here. So let me kind of show you what the potential issue is and what we're going to do to make sure we rectify it. So this is the crosshead that we poured the Babbitt on. The Babbitt is actually on the slide down here in the bottom, on the bottom of the crosshead. It's kind of backwards from most Babbitt bearings that people are used to, and I had a lot of people that were confused about that, I think, where they were assuming that we were going to Babbitt the area that was machined out, but instead the Babbitt is on the crosshead that's sliding back and forth in there, which is, again, kind of reverse from what most people think about, but it's perfectly fine. So we got this one poured and we set it up over here on the shaft so it was properly centered on the shaft and so forth. But here's the potential problem. And let me show you. This is the other crosshead for the other side that doesn't have the Babbitt poured on it yet. But in addition to having this thing centered up, obviously it can rock from side to side a little bit, and it has to be in alignment. Let me just set this one over here for the moment. There is a connecting rod that will come down inside of this, and this goes up to the crankshaft, which is back here. That's going to actually move this back and forth. And for this to work right, obviously it's got to be a proper alignment left and right. Now when I did this, I did the best job I could to get it where it was the same amount on each side. And I don't even think it was shown in the video. I actually spent a fair amount of time doing some measurements and stuff. It was off camera, but trying to get that lined up. But while I'm pouring this, I'm just like, I hope that when it all comes out, is this thing going to be properly aligned with the crankshaft, or is it going to need to be adjusted a little bit back and forth? A small amount we could probably take care of with scraping, but if there's too much alignment issue, we'd have too big of a gap in there and it could potentially be a problem. In retrospect, ideally, I think what we should have done was gone ahead and set this up with the crankshaft and with the connecting rod in place, and then everything would have been in proper alignment and wouldn't have had to worry about it. So before we pour this crosshead on this side over here, I'm going to do just that. We're going to go ahead and get the crankshaft put in here. We're going to get the connecting rods installed, and we will pour this one with everything properly aligned. And we'll also test this one to make sure that it's going to work. If for some reason it doesn't, again, worst case scenario, we just melt the Babbitt off and we re-pour that side as well. I'm hoping we don't have to do that. And I feel like with the measurements that I took and getting it lined up, I feel like it's probably, if not perfectly aligned, it's going to be close enough, but we'll just the jury's out on that. We're just going to have to wait and see. So today we're going to start working on getting the crankshaft put in here because that's really the next step, I think, to get these properly aligned to make sure that we're not going to have any problems down the road. So this is the crankshaft that goes in this engine. I've talked about this in previous videos. Basically, we had this crankshaft reworked. It was taken to a professional crankshaft shop. That's what they specialize in, is crankshafts for diesel engines and stuff like that. Even though it's a steam engine, it's a crankshaft. They were able to do it. Had seen a lot of wear over the years. It was actually a little bit undersized, and they had replaced the bearings in here with some slightly undersized bearings to match it at one point in time. When we had this redone, I went ahead and had them build these surfaces back up. They welded them back up using a special process that's made for doing crankshafts. They actually welded it underwater on a special machine, again doing that, and then they were turned and ground down back to the original specification. So these journals on this crankshaft are all within the original specs. Because this engine was worn and had been rebuilt in the past, the bearings were a little bit on the undersized side. So now we've got to make our bearings a little bit larger to make them match again to the new equipment that is back in spec. So on this crankshaft, there's 3 main journals. It's this one, this one, this one. They all measure 3 inches within a couple of 10,000ths of an inch. I mean, they're all pretty much right where they need to be. But we need to make the bearings a little bit larger. So again, 2 outside bearings, 1 center bearing. The outside bearings are bronze bearings. They're just bronze bushings that are up inside a little piece. These bolt onto the side of the main case. And again, they're just a little bit on the small side. We need to make them just a little bit larger. We'd rather do that, have material take out rather than need to add material in there. So that was kind of done on purpose that way. It's not by much. And we're going to measure them here in just a second. But we're going to start with this one. This bearing journal is the one that fits on this side. I know because this one, it's got a cap that you can screw on the, no, actually this goes on the other side. This one goes on the other side over there. This bearing cap actually fits on this side over here. This is the side that's closed up. There's a cap that fits on it. The other one actually has a seal in it where it'll come all the way through, and you got a kind of a power takeoff. This is where you hook up whatever you want on here to drive from. So let me grab the other one. All right, so we want to compare this bearing to this journal and see how much material needs to come out of them, and then we're going to work on getting that material taken out very carefully. So one thing to note here that I want to do before we go any further is I want to actually check my measuring instruments and make sure that they are calibrated to one another and are in tolerance with one another. Now, I'll make the comment right here. Most of the work that I do in my shop, I'm doing repair work. I'm not working off of a blueprint, making something to a specification. I'm making something to fit. And because of that, I'm not always overly concerned whether my micrometer is 100% in perfect calibration, because I'm making comparative measurements. Usually I'm measuring with the same tool that on both what I'm working with and against. So, you know, even if it's off by a half a thou or even a thou, because I'm measuring with the same thing, same measuring tool, it's kind of self-correcting. Again, I'm not shooting for a specification, I'm shooting to match something. In this case though, I'm going to be measuring the diameter with this micrometer and the bore with this bore micrometer or bore gauge. And I need to make sure that they're reading the same so that there's no error that's introduced in here. Pretty simple process. I've got a standard, this is a calibration standard for a micrometer. This one is 3 inches in diameter. It's just basically a ground rod. This got a little insulator on here so the heat from your hand doesn't cause it to enlarge ever so slightly. We're calibrating to 10,000ths of an inch. And I'm just going to check it here. I'm going to just tighten this up like I normally would. And I'm reading right here. Hopefully you can see that. That is reading dead on 0. So we're right at, that is exactly 3 inches. My micrometer is actually in calibration here, which I try to keep my tools in calibration, but it's not always important. Now the bore micrometer, again, I've got a standard. This is a ground out ring. This one is a 3-inch ring. I know this is 3 inches according to the standard within very tight tolerances. So we're going to drop our bore micrometer down in here. We'll measure the calibration ring and make sure that it also is reading right on the money, and it's reading right on zeros. So my two measuring tools are calibrated to one another, so I can measure with both of them and trust my measurements. Let's go measure the diameter, and then of the actual crankshaft journal, and then we'll measure the diameter of the bore and see where we need to go. All right, so this is supposed to be 3 inches according to the specifications. Again, we're working off a blueprint in this case. So let's see where we end up at. All right, so again, we're just, in this case, we're not right on the line, we're just a tad under. This is a 10,000ths reading micrometer, and it's reading 8/10. So we're about 2/10,000ths of an inch undersize on this journal. And I've actually already measured it, and depending on where you measure it at, it's within 2 or 3 10,000ths. So, you know, we can check it in multiple places here. And yeah, I mean, it's fairly consistent. It's within about a 10,000th across that surface, but it is just slightly undersized by just maybe 2 to 3 10,000ths. Now let's measure our bore over on this one and see where it's at. All right, so we're going to drop this down. This is measuring off of 3 points, so you get a really accurate measurement. Kind of get that rock out of it. And it is measuring on this one, it's about 2 10,000ths over 3 inches. So just slightly over 3 inches, but a little bit larger than where we're going to. And I noticed that this appears to be kind of tapered. As you go down into the bottom, it gets a little bit larger. We're about 1,000th over in the bottom and about right on 3 inches at the top. So it's not a perfectly straight. Now where we need to go to have clearance, you know, I don't want to press fit. I want this thing to spin, and I need to have a little bit of oil clearance in there. And according to the specifications I've been able to find, about 3,000ths clearance is what we need. So depending on where we are in this bore, I need to take anywhere between 2 to 3,000ths of an inch out of it to just very slightly enlarge it to get it to go to where it needs to be. Now, how are we going to do that? I'm going to show you how we're going to do that. Let's go over. I'm going to get this mounted in my vise, and we're going to work on enlarging it ever so slightly. Before we do, though, I do want to just show here this bearing coming up on here, and it won't quite go up on there. It's just a little bit too small. The bore in the bearing is. So let's go enlarge it. Got my bearing over here in the vise, and to enlarge this, what I've decided to use is I'm going to be using a reamer. This is not your normal everyday reamer. This is an expanding mandrel reamer or expanding reamer. Basically, the knives that are in here are in these little channels. These are all cut at a taper, and you got 2 threads on here. When you basically loosen this on the top, tighten it on the bottom, it slides these up the taper and it expands it out ever so slightly. Now, when I was making some adjustments to kind of get it roughly to size to start with, I was just measuring across these with a pair of calipers, and it looks like about 1 turn of this is expanding out the diameter by roughly 10,000ths of an inch. And again, that's just with some calipers. So once this thing starts cutting, it's not going to take a whole lot, because remember, we only need about 2.5 3/1000ths of an inch to get the proper clearance. So we just need to barely do. I'm going to start by really just barely touching it, and then we're going to make some very small changes in this multiple times, go back and forth, and slowly take this out till we get it to a size that'll fit up on there. So right now, I've got this where it will drop down in here, and when it does, I can literally spin it by hand but it is taking a little bit of a bite there, not much. I saw a few shavings come out, but I'm going to go ahead and take it out, and we're going to expand it out. Probably going to turn it about 1/10 of a turn, and then we'll come back and do this, and we'll just kind of go back and forth until we get it where it needs to be. So let me get this out of here, and I'm just looking, and it's making contact in just a couple of places, which tells me that bearing may not have worn perfectly round. And just to make sure, I'm going to get a quick measurement here. And I'm kind of measuring on the areas that it looks like it was cut in about 3 places, and I'm still just a little bit undersized. So anyway, we're going to make an adjustment to the reamer. It's going to be back and forth until we get it where we want it. So let me go make that adjustment. I'll show you that, and then we'll come back and do another cut. So I'm over at my smaller vise. I just got this clamped in here, and I need to go down with this. The taper is running from the smallest point to the largest diameter, and I'm just going to do that by turning this bottom, and I'm just going to give it just a least little bit of a turn. Like I said, maybe about 1/10 of a rotation, which according to my measurements earlier should be about 1/1000th of an inch. So just barely moving it. We'll tighten up the top. And now we're going to go take another bite. And again, we'll just keep doing this until we get the measurement like we want it. Let's see what we can do here. This is probably still going to drop down in here. Yeah, and I can actually mostly turn it by hand. Get a pair up here, some leverage up here on the top. All right. I'm changing the way I grip this. Hopefully help me kind of get it in and out a bit better. All right, I can see a little bit different wear pattern in there. We're still not cleaning up all the way around, but definitely tell there was some areas in there that was a little bit higher than others. I'm gonna go make another adjustment, come back, and then again, rinse and repeat until we get it where we want it. Took about 4 passes there with the reamer, and we got a really nice looking surface in there. I'm measuring just under 3/1000ths over, so I think we should have clearance now. We're going to take this off and go test fit it on the crankshaft. According to measurements, it should fit and have that oil clearance that we need. I will note that these are oil grooves in here that are machined into that surface for the oil to be able to distribute across there. And that reamer did leave just a couple little marks in there, but again, overall it's round. And those areas that we got a little mark in there, no big deal. That's just going to basically be a little oil journal. So we should be good. Let's go check it out. Back over at the crankshaft, I'm going to put a little layer of oil on here, just because. Make sure we got some lubrication in there. We'll take our bearing. Oh yeah. That is nice. Just what we want. See, it's hitting on the, there we go. That's all the way in there square now. It was hitting up against the machine back here. Man, that is smooth. I don't really feel any play in there. I think that's about perfect. All right, one down. We got another one to do just like this on the other side. The middle bearing is actually in the Stoker case over here. That was going to be a little more challenging, but we'll get to it in a minute. I'm going to go ahead, I'll probably just do it off camera. Same process as this one. We'll get the other side done as well. So I think we're ready to put this side on and test fit it. Interesting to note on this journal or bearing, there was very visual, clear wear in this direction right here. When I first started reaming it out, it was only touching on the top and the bottom. It wasn't touching on the sides. And I had to take about 3/1000 out of it. And in the process of that, it did clean up completely, but anyway, small wear, but noticeable wear in the original. We're about the same diameter as the other side. And this measures pretty much identical to the other side. So in theory, we should be good to go. So let's slide that up on there. See what this side looks like. Oh yeah. Man, that's nice. I like it. All right. 2 bearings down, 1 to go. Next one's going to be the challenging one. So on this one, obviously our bearing is fixed in the center. I'm going to have to do it in place here. But before I do, I need to get this properly set up. So I just got some bolts holding this together right now. I need to take these off. There were some spacers in here. I need to find those and get those put back in, and then we can start hopefully reaming this one out as well. Let's get it taken apart first. I thought it was interesting how they machined out these places right here, obviously so that a socket will fit down in there, because you can't get a wrench in it. Wow. All right, I've gone to a little bit shorter extension, and we got this on a, instead of a ratchet, I've got it just on a pull handle, because I'm putting a cheater bar on here to help break this loose. My word, that was tight. We'll get all these off. And let me see if I can find my shims that should go back in here. And these bolts get replaced with studs and nuts to get it back to the original configuration. So let me get all that worked out. We've got those bolts removed, and these will be replaced with studs. I got those ready to go in here when we're ready here in just a minute. I pull this up, and oh good, I see that the shims that were in here, I left them in here. That's really good, because I was concerned that wasn't sure that I had the right shims for this. So I think what I'm going to do is I'm just going to go ahead and put this back together, and I want to go ahead and get my studs mounted in here. This is a 3/4 inch by 3 inch stud. There's 4 of them. And on the originals, there were 2 jam nuts that tightened all these together. The 2 jam nuts basically jammed on one another. I'm just going to put a single one in at the moment, because I just want to get it torqued down. We'll put the final 2 nuts in here when we put it together eventually, but right now I just want to get them tightened up. So there is a little bit of play on this. I want to just kind of feeling that gap in there. I think I got it pretty good. I'm just going to snug these up. And I'm just going to use my bore micrometer here. I want to see where we are to start with. And it looks like we're all right, I'm going to dig around. I'm about 25 thousandths smaller than what I should be. So I'm thinking I might be missing some shims. Let me dig around and see if there's some more shims that might go in there. So I dug around over there, and sure enough, there's a shim that we missed that wasn't in there. So I'm going to take this cap back off. And it's probably going to be a little bit of a trial and error here. I don't know for certain that I've got all the shims that came out of there. I do know that I tried really hard not to throw anything away. So I'm hoping that we got everything. All right, I'm going to take this apart. All right, I made one new shim, and about the same thickness as the one that I took out, or the one that I added a while ago. And we're measuring 301 right now, or 3.001, 1,000ths over 3 inches. I need to be about 2.5, 3 thousandths over, so I got just a little bit more I need to take out of this to have a good fit. And we're just going to try to use the expanding mandrel, or expanding reamer rather, to do that as well. But we're really close, and let's see what we can do here to get that one to size, and we'll be ready to try to put this crankshaft in. So I went over and cut another shim using the original one as a template and put it in here, and now I'm measuring just right, actually just right where I need to be. I'm about 2 thousandths over 3 inches right there, and just depending on where you measure it, it's all of them are measuring just a little bit over. That one's about 203, or 3 thousandths over rather. I think before I try to do any reaming on this, I'm going to take this top cap off and just go set it on the crankshaft over there and see if it kind of fits. And if it does, I may just try to put this together like it is, because it looks like this bearing here with the shims in there like I have it right now isn't going to really need any adjusting, or very little adjusting. So before I take off material that I don't need to take off, I want to test fit it, because it's hard to put it back on once you take it off. It's pretty easy to take more off. I'd rather sneak up on that final number than to get too aggressive here to start with and take off too much. So let's try it on for size and see how, at least I can at least take this over to the crankshaft and see how it fits, and then make a decision on to try to fit the whole crankshaft in here or not. Let's just fit it on there. I can look down the oil holes and tell we're making contact in the bottom. No rock side to side. That feels pretty good. I think I'm going to try to drop this in. We'll just see what happens. We may not have to do any adjusting to these bearings, which would be awesome. They're measuring right on size if my measurements are right. The only thing that I'm a little bit concerned about is I really don't have a way to check and see how round this bearing is. You know, with the other bearings we did with the reamer, you know, I know one of them was out of round just a little bit, but we straightened that out with the reamer. These I'm not as sure about, but they're not going to be out by much, and probably within the tolerance of that we have. So we're just going to try it and see what happens. Let's see if we can put that crank in. You can see my two new shims that I made. I actually made two new shims, and I took the old shim the thick shim out. I was going to, if I needed to, I was going to put it back in, but this seemed to get it. So I'm going to start by just putting a little oil in here. I'm going to drop this down in there carefully. Kind of get a test fit. And it's rocking a little bit. So what that's telling me is it's not seated all the way down in the bottom of that bottom bearing. The top bearing seems like it's fitting fine, but the bottom bearing is rocking. Just out of curiosity. Yeah, that top bearing feels pretty good. It's not tight, obviously, but all right, I was hoping we weren't going to have to do any modification to the bore of that, but it looks like we are. So the next question is how do I want to go about doing this? Let me pull this back out and we'll see what we can come up with. Well, I can see a problem that we're going to have here with the reamer. Because this is a straight bladed reamer and the edges, the sides are opposite of one another, and this is a split bearing, as we turn the reamer, it's going to want to catch in these little gaps that are between here. It's not going to want to make a full circle. To use a reamer on this, we would really need one that has kind of a helical shape to it so that we didn't have a flat that could get into those corners. So, all right, let me think about this. Guys, I have fiddled around with this, and I apologize, I did it off camera. I was just kind of doing some things trial and error. I'll tell you what I did is I ended up using a 3-sided hone here and went up in there with everything together, and I just honed it out a little bit. The gaps on these were just wide enough they didn't catch in those grooves like the reamer would have or was. So I was able to do some trial and error and do a little bit, take it apart, put it back together. I'm pretty happy where it's at right now. Just put some oil in there, that's going to even loosen it up even more. But yeah, that's it's turning pretty good. You know, it arguably could use just a little bit more. And when I take it back apart, I might hone it just a little bit more, but I think for right now, that's going to be good enough. So let me see if I get putting these end caps on and see how it all lines up. All right, guys, this is a milestone. We've got the crankshaft installed. Like I said, it's a little bit tighter than what I want in the final version, but this helps me out a bunch. It kind of tells me where I need to go. I can tell that I think most of what I need to work on is going to be the center bearing. Probably just need to do a little more honing to it. I would rather sneak up on that again. It's easy to take metal out. It's hard to put it back in. So this is kind of a trial and error process until we get it just right. But it is feeling pretty good right now. And well, it feels acceptable right now. We got it spinning anyway. And for what we need to do to kind of fixture this thing together, this is going to be good enough. Like I said, it's all going to come back apart. When it does come back apart, we're going to fine tune these bearings and get it where it will spin pretty much effortlessly, which is what we want. But headed in the right direction. So with that, with the crankshaft installed, at least temporarily, I think that's going to be a wrap for today. The next step, I think, is going to be we need to get the wrist pins completed for the that will allow us to connect the connecting rod to the crosshead. I think I got some new wrist pins made. We need to do a heat treat on those, carburize them, or do a case hardening, and then get those ground to size. So that's going to be the next step that I get to work on in this project. And but we are, again, headed in the right direction. Guys, with that, that is a wrap for today. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up, those comments, they really help out a lot, and I really do appreciate you guys to do that. Also, big, huge thank you to those who support the site financially through Patreon, PayPal, and now through YouTube memberships. All those are a great way to help out myself or any YouTube creator that's out there that participates in them. It just gives a little bit of extra income coming in. You know, if you've got a channel you really like and you get a lot out of, consider contributing a little bit more, because the money we get off the ads, it's not that great. So the little bit of extra that comes from our top fans out there, or the people that feel like they're getting the most out of it, it really does make a big, huge difference. Thank you to those guys that do it, and I encourage you to take a look at that if your means allow you to do so. And with that, we're going to sign off. We'll catch you on the next video. Again, as always, thanks for watching.